Okay, see Lindelof videos, basic integration rules. I want to go over some rules of trig. I think I'm going to go over 6 of them with you right now. What I want to do is this. I keep talking about the fact that integration and differentiation have these inverse qualities to one another. So I kind of want to demonstrate that with these first three instead of just giving you the integration rules. So here's the differentiation rule. We know that d dx of sine x is equal to cosine x. Well, if we do this backwards, if we kind of do this in reverse, if we take the inverse, we could say, well, then the indefinite integral of cosine x dx is equal to sine x plus c. I'm just switching these things and putting in this integration sign. To do the same thing here. So, okay, say that d dx of cosine x is equal to negative sine x, or opposite sine x. Then we could say, well, then this is my therefore sign. Therefore, the indefinite integral of sine x dx is equal to cosine x, right? Is equal to opposite cosine x dx. Not dx. What is wrong with you, boy? I'm sorry. Plus c. This is our constant of variation, isn't it? And then lastly, and I'm not done with this. I'm going to give you the other three rules. I'm not going to break them all out as much as I have here. I'm going to take this and say, well, if this is true, then wouldn't it be safe to say that the indefinite integral of secant squared x dx would be equivalent to tan x dx, wouldn't it? I'm sorry, tan x. I don't know why I want to keep giving that dx. That's actually not true at all. Tan x plus c, my constant of variation. And if you know me at all, I hate my constant of variation. I forget it all the time. But if you're taking the AP exam, if you forget it, they're going to take a point. So let's try to get you in a better habit than I have. I'm going to just give you these last three rules, and I'm just going to do it on this side and say this, that say that the indefinite integral of secant x tan x dx is equal to secant x plus the constant of variation, isn't it? And then the next one just kind of follows. And if you can do these rules of differentiation backwards and get right back to all this stuff, in this case, you would have had that the first derivative of secant x is equal to secant x tan x. So we kind of know that. So I'm just following that and trying not to waste all of your time. And the same thing here, I'm going to say that the indefinite integral of cosecant squared x dx is equal to opposite cotan x plus c. I'm going to continue to remember my constant of variation there. And the last one that I want to give you today before I sign off with you is that the first derivative of the indefinite integral. Wow, the indefinite integral, or the indefinite derivative of secant x dx. You know what? I didn't want to do that. Secant x cotan. Oh my gosh, cotan x dx, because that comes from our derivative, doesn't it? Is opposite cosecant x plus c. Sorry to turn that around a little bit. All this stuff, you just have to kind of put it into your brain and memorize it. I say put it on flashcards, take pictures of it, and put it in your iPhone, whatever it takes. This is stuff you have to have memorized because the application of it is what's really important. The memorization of this crap, and your professors may disagree with me, but the memorization of this crap is far less important in its understanding. You just have got to get it memorized. So I hope the video is helpful to you. If you have any questions or comments, please let me know. And if you haven't already subscribed, please do. Thanks, you guys. Appreciate it.